Hello students, myself Professor Jalpasha, Assistant Professor in Computer Engineering Department, Aditya Silveroak Institute of Technology, Silveroak University. Today we are going to see the one topic of the subject, that is analysis and design of the algorithms. In short, it is known as ADA, which comes under the 5th semester of the curriculum of the university. So now let us start with the topics of today's. So outlines are that today we are going to see the insertion sort, in which we are going to see the example of it, algorithm, analysis of it, and the C program of the insertion sort. So first of all, let us understand that what are the learning objectives of it. So interpret the code for the insertion sort, trace the code for the insertion sort algorithm with input data, identify factors that could influence the efficiency of an insertion sort implementation. To be able to explain and implement the insertion sort. So now, first of all, let us understand that what do you mean by insertion sort. So in this method, the elements are inserted in their appropriate place. Hence, the name is known as the insertion sort. So the total number of passes for this sort will be n-1. It is very simple to implement. So this method is very efficient when we want to sort the small number of elements. So now let us start with the example of the insertion sort. So the array elements that we are taking, that is 30, 70, 20, 50, 40, 10, and 60. So now let us understand that sort the given elements using insertion sort. Here, first of all, we need to understand that yellow color will represent the shorted zone, whereas light green shade will represent the unshorted zone. Now, let us start with the example. So here, first we are considering that 30 comes under the shorted zone and all other remaining elements come under the unshorted zone. So now let us start that first we are giving 30 to J pointer and 70, that is start with the I pointer. So now here we will start with I equal to 1. So J equal to I minus 1, that is equals to 0. So temporary equal to A of I, that is 70. Now we are putting here. Now let us take one comparison, that is while J is greater than or equal to 0 and A of J is greater than 10, that is equals to while J is 0, so 0 equal to 0 and the A of J is 30 and temporary is 70. So here we need to see that is A of J plus 1 equal to A of J and J equal to J minus 1 and then A of J equal J plus 1 equal to temporary. Here you can see that condition will become false. So simply we need to increment the pointer J, I both. So here we are taking I equal to 2. So J equal to I minus 1, that is equals to 1. So temporary equal to A of I equal to 20. So while J is greater than or equal to 0 and A of J is greater than 10, then A of J plus 1 equal to A of J, J equal to J minus 1. Here first, let's do the comparison. So J is 1. So 1 is greater than or equal to 0 and A of J is 70, which is, and temporary is 20. So condition will become true. So A of 2 will become 70, J will become 0 and A of J plus 1 will become A of J plus 1 will become temporary. So that is A of 1 is equals to 20. Now again, here J will be decremented. So temporary equal to 20. Again, we need to compare, that is J is 0. So 0 is greater than or equal to 0 and A of J, which is 30, is greater than 20. So now it will go into the loop. So A of 1 will become 30, J equal to J minus 1. So J will become minus 1 and A of J plus 1 equal to temporary. So A of 0 will become 20. So your array will become 20, 30, 70, 50, 40, 10, 60. So here you can see that yellow represents the shorted zone, whichever becomes, and light green shade will represent the unshorted zone. So now again your I and J. So temporary equal to 20. So while J is greater than or equal to 0 and A of J is greater than 10. So while minus 1 is greater than 0. So by default, this condition is going to become a false. So now again your I pointer is going to be incremented. So I will goes on a 50 and j will be -1 to it. So on a 70, your j pointer will be designated. So I equal to 3. So j equal to I -1. So j will goes on a 2 index. So temporary equal to a of I equal to 50. So while j is greater than or equal to 0 and a of j is greater than 10. So while 2 is greater than or equal to 0 and 70 is greater than 50. So a of 3 equal to 70 where j equal to 1. So a of 2 equal to 50. So now your j pointer will be decremented. So temporary equal to 50 while j is greater than or equal to 0 and a of j is greater than 10. So while 1 is greater than or equal to 0 and 30 is greater than 50. So condition will become false. So here 70 will comes into the shortage zone. Now again your I pointer will be incremented. So I will goes on a 4. So j will become 3. So temporary equal to a of I equal to 40. So while j is greater than or equal to 0 and a of j is greater than 10. So a of j plus 1 equal to a of j. So while 3 is greater than or equal to 0 and 70 is greater than 40, both condition will become true. So a of 4 will become 70. J will become 2 and A of 3 will become 40. So data will change. You can see in the red, data is changed. So now your J pointer will be decremented. So temporary equal to 40. Now in condition that is while 2 is greater than or equal to 0 and 50 is greater than 40, your A of 3 will become 50, J will become 1 and A of 2 will become 40. So by red, we are seeing that it is changed. Again, see the j is 1. So 1 is greater than or equal to 0 and 30 is greater than 40. So condition will become false. So now you can see that your 5 elements will come in a shortage zone, whereas 2 are remaining, which will comes under the unshorted zone. So now your I will become 5. So j equal to I -1, that is 4. And temporary equal to a of I, that is 10. So while 4 is greater than or equal to 0 and 70 is greater than 10. So a of 5 equal to 70, whereas j equal to 3 and a of 4 equal to 10. Now you can see the red marked data is changed. Now again j will be decremented. So while 3 is greater than or equal to 0 and 50 is greater than 10, condition become true. So a of 4 equal to 50. J will become 2 and A of 3 equal to 10. So data is again changed by red marking. Now J will be again decremented. So while 2 is greater than or equal to 0 and 40 is greater than 10. So A of 3 equal to 40. J will become 1 and A of 2 equal to 10. So again it is changed by red marking. Now again your J, that is 1. So 1 is greater or equal to 0 and 30 is greater than 10. Again condition satisfied. So A of 2 equal to 30, J equal to 0 and A of 1 equal to 10. So again data is changed by red marking. Now your J will become 0. So 0 is greater than or equal to 0 and A of J is 20 and temporary equal to 10. So 20 is greater than 10. Condition becomes true. So now A of 1 equal to 20, J will become -1 and A of 0 equal to 10. So now you can see here that is while -1 greater than or equal to 0, condition will become false. So it will stop decrementing and you will get your array sorted, that is for the 6 elements. Now your I pointer will be incremented. So 60 will be in an unshorted zone, whereas all other remaining data will be in a shorted zone. So now while 5 is greater than or equal to 0 and 70 is greater than 60, you can see A of 6 equal to 70, J equal to 4 and A of 5 equal to 60. Now your J will be decremented. So while 4 is greater than or equal to 0 and 50 is greater than 60, condition will become false. So it will stop decrementing. So here you can see that your whole array is going to be shorted. So now let us understand the algorithm for the insertion sort. So first of all, the name of the algorithm, that is algorithm insertion, A of 0 to n minus 1 elements. Problem description is that this algorithm is sorting the data using insertion sort. Input the array of elements A of 0 to n minus 1 that is to be sorted. Output, that is the sorted array. Now your outer loop, that is for I equal to 1 to n minus 1 do. Then temporary equal to A of I, j equal to n I minus 1. Whereas one condition, that is the most important condition that we need to put, that is while j is greater than or equal to 0 and A of j is greater than 10, then do A of j plus 1 equal to A of j, then j equal to j minus 1. Now A of j plus 1 equal to temporary. So here your whole algorithm is done. So here you can see that is the loop. Now the analysis that we need to see, that when an array of elements is almost sorted, then it is the best case complexity that we all know. So the best case complexity of the insertion sort, that is big O of n. Now, if an array is randomly distributed, then it results in an average case complexity. So the average case complexity is big O of n squared. If the list of elements is arranged in a decreasing order or a descending order, and if we want to sort the elements in a ascending order, then it results in a worst case complexity. So the worst case time complexity of the insertion sort is big O of n squared. So now let us understand the program of in a C language for the insertion sort. So for that, we need to first of all open the Turbo C program. So that is the, let's open this. So let's start the Turbo C software. From that, take a new file and let's start implementing the program. So first of all, we need to include the header file, that is include studio.h, which represents the standard input output header file. Next is has include conio.h, which represents the console input output header file. Now, first of all, we need to create a main function, that is void main, the brackets for this function. Now in this, first of all, let's declare the variables. So integer I, j, n, temporary, and A of 20, that is the n. Now the function, that is clr_scr, that is used for clearing the screen of the previous output that we are getting. Now first of all, let's take the number of elements from the user. So printf, enter the number of elements. Now scanf %d, comma, ampersand n. Now we need to take the number of the elements from the user. So for that, printf, enter the elements. So we need to take that using a for loop. So I equal to 0, I less than n, I plus plus. So here I need to take that is scanf %d, comma, ampersand A of I. So here we have taken the data from the user. Now we need to start the sorting. So the main logic of the insertion sort that we need to implement. So for I equal to 1, I less than n, I plus plus, that is the main for loop for it. Now in between, what we need to write, that is temporary equal to A of I, that we need to assign first. Then j equal to I minus 1. So j pointer will be always 1 minus than the I. Now we need to take a one loop, that is while j is greater than or equal to 0, so that here we need to take two conditions. So let's take it in a bracket, and then a of j is greater than temporary. In that, what we need to do? We need to assign the values, that is a of j plus 1 is equals to a of j. And we need to decrement the value of j by 1. So j equal to j minus 1. After performing all this, what we need to do? That is a of j plus 1 equal to temporary. So here the main logic of sorting that is done. So now what do we need to do? We need to print the sorted elements. So printf percentage d slash n comma a of, or first of all we need to print one message, that is printf sorted array. And this we need to print using the for loop. So for I equal to 0, I less than n, I plus plus. Here in this we need to print, so printf percentage d slash n comma a of I. So this will print the array elements. Lastly, we need to write a command, that is get ch. So here you can see that your program is over. So now first of all, let's save this file as in a bin folder of turbo C, that is insertion dot C. Now we can run this program. First of all, we need to compile to check the errors. There is no error. So now let's run this code. So here number of elements are 5 that we need to sort. So let's take the elements, that is 4, 2, 5, 3, 1. Here you can see that the output, the sorted array is 1, 2, 3, 4, 5. So here we can see that using the insertion sort, we have sorted our array. So now let's close this turbo C. And here you can see that we have completed our whole practical. So in today's session, we have seen the, first of all, the example of the insertion sort, then the algorithm of the insertion sort, then the analysis and the C program of the insertion sort. So here we have completed the whole insertion sort.